tutorial. So we'll continue our discussion related to some basic concepts related to electrical machines. In the previous video we discussed some important properties, some important parameters associated with magnetic effects of electric current. So in this video we are going to discuss about magnetic materials, the different categories in which we can divide magnetic materials, and some basic concepts related to it. So first, all materials depending upon their important magnetic properties which we have discussed previously, such as magnetic flux density, permeability, susceptibility, they are affected by external magnetic fields. When any material is placed in an external magnetic field, it gets affected. Now some, they get weakly magnetized, that means they attain magnetic properties to a very small extent, while some acquire strong magnetic properties, they get magnetized to a large extent. Now why some get weakly magnetized, some get strongly magnetized, that can be expressed on the basis of the atomic theory. Now we have already discussed magnetic dipole, how atom behaves as a magnetic dipole. So we know that an atom, it consists of electrons orbiting around the nucleus. So the revolving electrons around the nucleus, they behave as an electric current and produce a magnetic field. Now we have already discussed how a current loop, it behaves as a magnetic dipole. So suppose we consider a plane loop of current carrying a current I. When we see the top face, from the top side, the current appears to be moving in anti-clockwise direction. That's why it acquires north pole. When we look at from the bottom, it appears as if the current is moving in clockwise direction. That's why it acquires south pole. Similarly, when an electron, it revolves around the nucleus with a certain velocity, a current flows in the opposite direction, because current direction is always opposite to the electron movement direction. So this current flowing is similar to this plane loop of current, and that's why the atom, it behaves as a magnetic dipole as a whole, because of the movement of electrons in the various orbits around the nucleus. So this magnetic behavior of atom, it is expressed as the orbital magnetic moment, which is given by NEh by 4 pi m, where n is the number of orbit, E is the electronic charge, h is Planck's constant, m is the mass of the electron. Here this EH by 4 pi m is called as Bohr magneton. Okay, so this is why the materials, they behave, they respond to a magnetic field, or they acquire magnetic properties. So on the basis of this, magnetic materials can be classified into three categories: diamagnetic materials, paramagnetic materials, ferromagnetic materials. In this video we will be discussing only about diamagnetic materials. Paramagnetic and ferromagnetic materials will be discussing in separate videos. So diamagnetic materials. So diamagnetic materials are those, when placed in an external magnetic field, they get weakly magnetized, or they acquire magnetic properties to a small extent in the opposite direction to the applied external field. So it means that when this diamagnetic material is placed in the external magnetic field produced by this permanent magnet, this extreme end, which is facing the north pole of the permanent magnet, it acquires a north pole, and the other extreme end facing the south pole of the permanent magnet, it acquires a south pole. So that's why this end repels this north pole and this south pole repels this south pole. So it always gets repelled because of the external magnetic field. This is what diamagnetic behavior is. Examples of such materials are bismuth, copper, zinc, silver, gold, air, water, hydrogen, etc. So here the resultant magnetic field inside the material is always less than the external field, which is evident because it is weakly magnetized, and it is a very weak form of magnetism, and as long as the external field is removed, the material, it loses its magnetic properties. Okay, so why the diamagnetic materials behave in that way, why they acquire a weak form of magnetism, why they are weakly magnetized? So again, here the magnetic dipole moments come into play. So again, the electrons in the various orbits of the atom, they revolve around the nucleus and possess magnetic moments. In case of diamagnetic materials, what happens is that the magnetic dipole moments, they always exist in opposite pairs. Okay, so as they exist in opposite pairs, equal in magnitude, opposite in direction, so they always cancel each other out. Okay, so the magnetic dipole moments in diamagnetic materials, they exist in opposite pairs, equal in magnitude, opposite in direction, so they always cancel each other out. So the net resultant orbital magnetic dipole moment in case of diamagnetic materials is 0. So as a result of this, the diamagnetic materials, they are very weakly magnetized. When they are placed in the external magnetic field, they acquire some value of magnetic dipole moment, which is very small, and is not enough to sustain the magnetic properties for a long period of time. As long as the magnetic force, external magnetic field, is removed, they again align in their original directions, which is again opposite pairs, and they cancel each other out. Okay, so some important properties of diamagnetic materials. So diamagnetic materials are repelled by the external magnetic field. It is evident because north pole is towards the north pole of the permanent magnet, south pole of the material is towards the south pole of the permanent magnet. So obviously there will be repulsion, as the magnetic properties are weak in the diamagnetic material, so the repulsion is also weak. Okay, they are weakly repelled. Then when diamagnetic material is placed in the external magnetic field, the magnetic lines of force, they pass around the diamagnetic material, but they do not pass through it. It is self-explanatory because they get repelled by the external magnetic field, weakly repelled, but they get repelled. That's why the magnetic lines of force, they never pass through the diamagnetic material because of this behavior, north towards north, south towards south, so they get repelled. Then when diamagnetic material is suspended freely in an external magnetic field, it always aligns itself with its longest axis, this axis, okay, with its longest axis at right angles or perpendicular to the external magnetic field. So this is the magnetic line of force, let's say, this is the longest axis, so it is always at right angles. Again, the reason is because of repulsion by the external magnetic field, because north pole faces the north pole, south pole faces the south pole, so it always gets repelled. This gets repelled and moves in that direction. This south pole it repels and it moves in this direction, and it acquires this final position with its longest axis at right angles to the magnetic field lines. Okay, then when it is placed in a non-uniform magnetic field, it moves from stronger to weaker parts of the field. Okay, now the important properties which define the magnetic materials: permeability and susceptibility. Now we have already discussed permeability as the conductivity for magnetic field lines. Now as you can see, the diamagnetic materials, they do not allow any magnetic field lines to pass through it. So obviously the permeability of diamagnetic materials is very less. It is always less than 1. Okay, that's why they do not allow any magnetic field lines to pass through it. They always pass around the diamagnetic material. Okay, so the relative permeability of diamagnetic material is less than 1. Next is susceptibility. It is the relative ease with which a material gets magnetized. The relative ease, that is the ratio between the intensity of magnetization and the magnetizing force. So the susceptibility of a diamagnetic substance has a small negative value. Okay, the magnetic susceptibility is small negative value. Again, because the diamagnetic materials are weakly magnetized because of the cancelling of the magnetic dipole movements, so they are not easily magnetized. They cannot be magnetized very easily. So that's why the susceptibility is also very low, almost negative value. And also the permeability, the conductivity of magnetic field lines of force, no conductivity, so permeability is also less than 1. Susceptibility is less, negative value, permeability is less than 1. So diamagnetic materials, as you can see with all its properties, they are it is a very weak form of magnetism, weak magnetic properties. Okay, and also the magnetic susceptibility of diamagnetic substance, they do not change with temperature. Okay, so these are the important concepts related to first the magnetic materials, based on how different materials they acquire magnetic properties, why some materials attain weak form of magnetism, some strong form of magnetism. It is because of their orbital magnetic dipole movements, because of the movement of electrons around the nucleus and the orbital magnetic moment. Then the classification of magnetic materials. First we have discussed diamagnetic materials. Next we'll be discussing paramagnetic and ferromagnetic in separate videos. Diamagnetic materials, very weak form of magnetism, and the magnetism, it is it happens for a very small period of time in the presence of external magnetic field, and as soon as it is removed, it loses its magnetic properties. So I hope you like this video, and please subscribe my channel Engineering Tutorial for more such videos related to engineering, science and technology. Have a great day. Thank you very much.